Things are about to get a little bit dry, unfortunately, a little bit more technical. My name is Leo Gagel. I'm the propeller head of the operation, so to speak. In my day job, I'm dealing with online learning, and I'm a database person by background. So please, if I get too technical,
we'll check the CO2 levels, Leo.
Yeah,
all right.
Please clean out. Keep this as interactive as possible as well. If you want to ask questions. So these are the main areas I want to talk about. Jim just mentioned the Thing network. I'll go into that a lot more. John also mentioned open hardware and open source software, so I'm just going to go a little bit into what are the main projects that we're using and why. And then the fourth and fifth is really sort of, as you gathered from the slides, we talk a lot about open for a variety of reasons. And one of the most important ones for me is the whole open innovation piece, which really means doing things out in the open, sharing it openly, because in the essence of sharing and working with other people, the sum generally tends to be a lot greater than the part. And then when it comes to funding, obviously funding is always a huge problem for us also as a non-for-profit. Probably forgot to mention, we are in existence thanks to a Premier's Award that we got out of the first project that Jim mentioned, the What Grows Here. So we were the first recipients of the Premier's Award, which started our organization. But we have to be very mindful of sustainability and keep going. So in future, we're hoping to use the concept of crowdfunding a little bit more. Just to sort of set the scenes, this is the Thing Network Manifesto. Everything that carries power will eventually connect to the internet. And we're pretty much at the start of this. At the moment, it's pretty much the Wild West, and things are not necessarily done very securely. So some of those things that are connected to the internet probably shouldn't be right now. But all of this is a learning experience, and we're very much learning very quickly. Now, the Thing Network. The Thing Network is a radio network for the Internet of Things that's established from the ground up, open, and as a crowd-funded exercise. It was started out of the Netherlands. I'll play a YouTube video in a second of the guy that started, and here's a better way of explaining the concept. But this is just the current map. I made this copy on the Saturday, I think, on the weekend, of the current Thing Network community. So that's not just the gateways or the devices. These are actual communities, and we're talking communities in Amsterdam, for example. They now have over 300 people. In Adelaide, we're now over 30. Sydney has about 70 members, so that's also, I have to admit, one of the reasons why we're here. We're obviously very open for new members, people that want to play in that area, and more than welcome to join either the Growing Data Foundation or the Thing Network. So we'll have some links. So the Adelaide community is certainly on the lookout for more people. We're also running a meetup every month, probably the second month, in various places. The last one was just a week ago at Buddy Networks in town. So again, I encourage you guys to look up the Adelaide Open Data and IoT meetup. It's also a couple of teachers, and as you probably gather, we've got a number of educators on our foundation anyway. So I might just quickly switch over. I have that preloaded, just bear with me a second.
Sometimes they're held in pubs, aren't they, as well? Yeah, very
that is correct. The seven stars is one of our...
That's an important aspect as a teacher, so it's a very beautiful, casual thing to really get those conversations.
Exactly.
Low CO2 levels.
That's right, everything.
High other levels.
It's actually outdoors.
Just on the YouTube volume, probably.
Yeah.
There you go.
A global, crowdsourced, open, imagine an Internet of Things data network that's created by the people and free and open for everyone to use. That's our mission at the Things Network. We are a group of people that is building a global, crowdsourced, open, free Internet of Things data. New technologies allow for things to connect to the Internet without Bluetooth, 3G or Wi-Fi. This technology is called LoRaWAN. It's very battery efficient, so devices can last up to 3 years. It's long range, it has a reach of around 10 kilometers, and it's low bandwidth, ideal for the Internet of Things. The good thing is that this network can be built a fraction of the cost of traditional normal data networks. The bandwidth used by LoRaWAN is open, and the network equipment is low cost. In the old world, building such a network was up to large corporations. We built the network ground up, funded by its users. So with a small group of people, it's possible to provide data connectivity for an entire city. It's our mission to support that globally. The city of Amsterdam was covered in 4 weeks, and use cases were built on top of that, starting from the first day.
We experienced that contributing to the network by purchasing and installing a $1,200 gateway is still a very big step to contributors. Therefore, we decided to take the production of a $200 gateway in our own hands. That is when we talked to John from Product HC 2000.
Hi, I'm John from Pedare, and we are a product design agency focused on smartphones. Our team has over 10 years of experience in connected devices and getting them to mass production. Over the past 6 months, we worked on LoRaWAN, and then we heard from the Things Network, and of course we're in the detail. Together with the community of the Things Network, we developed 3 products that we offer you to get started with LoRaWAN right away. The first one is the Thing Gateway, and it's a $200 alternative to all these expensive ones. And it will allow everybody to start a hotspot from their homes up to 10 kilometers of LoRaWAN range. The second one is the Things Uno. This is a development board. Based on the Arduino Uno with built-in LoRaWAN connectivity. It allows for very easy prototyping like you used to with the Arduino platform, but now right on the Things Network. The third one is the Things Node. And this is actually a remote that has built-in temperature sensoring, motion sensoring, nozzle light sensoring, and an RGB light and a button, all in a waterproof battery-powered case. This node is perfect for testing all kinds of user cases without ever fiddling around with hardware. After the Kickstarter, we make all our code and designs open source, enabling everybody to make better or cheaper LoRaWAN products, all in the philosophy of the Things Network. To make the Things Network global, we need everybody's help. That way, when you buy a gateway, we make sure that we update the region so everybody can keep track of our products. Some of our packages even contain complete packages. This way universities or governments can unlock a campus or even a whole city. To get you started with LoRaWAN, we even have classes, including a workshop with one of our community members to teach you how to work with these kind of tools. Together, we can make this. Join us today.
So that was a really nice produced version of it. The reality was slightly different. So, for example, we are still waiting for this gateway. So it was supposed to actually be shipped a year ago. However, it is actually being.
The Internet of Things is changing much about the world.
The autoplay on YouTube. So, So we are just on the verge of this being shipped, so that it has actually finally passed all the electronic testing or testing of the hardware itself. So the manufacturing is in process, and these gateways will be shipped. The other bit that I noticed on there, the price was at €200. It has now unfortunately moved up to €300. So the realities of hardware development and funding these projects have also been done. On the positive side, it's actually a much more capable product now as well than they were initially planning. So what I have put up there really is a bit, and also sorry, so just from an Adelaide perspective, you noted there that they covered the whole of Amsterdam in 40 days. In Adelaide, this has been a little bit more challenging, so we have at the moment 4 gateways up and running. One of them is at the Adelaide High School. We have Adelaide City Council funded 2, and our partners, eResearch Australia, South Australia, sorry, South Australia have also funded 2 gateways. We have 8 more coming, 8 more of those thin network gateways, and that is another reason why I'm here. So if there's any schools that want to make this available to the students, please come and talk to us afterwards. We're more than happy to assist where that's possible. So this is really a very quick overview of how this network actually works. So you have what's called nodes, and these nodes could be anything, sensing anything from humidity, radiation, nitrous oxides. Stephen mentioned quite a few of those sensors before anyway, but the difference is that they are on this LoRa technology, which means long range, ultra low power really. A question I always get is, can you send video over that? So it is really an ultra narrowband network as well. So we're talking bytes rather than megabytes that are sent. But it is extremely factor efficient that these devices can. We have now got devices that claim, obviously nobody has been able to test that yet, over 10 years on a 3.3 button cell battery. Then there is a small number, and the 10K was meant. The data that we've got is 15K in line of sight, so in rural situations. In cities and built-up areas, it's about 2.5 to 5 kilometers radius, so you can actually cover very large areas with a gateway that would probably cost below $1,000. So we're trying to get obviously as many of those, and with a radius of 15K, there's not that many you need. As you can see, could see there 40 for the whole area of Amsterdam. And then there's an open source Thing network server. These services used to be run by the Thing network out of Amsterdam. We were connecting to either a European server or a router that was made available by Singapore. But as of 2 weeks ago, we now have a fully Australian-based network as well. So there weren't any problems before, but latency is obviously going to be a lot better now. This basically takes care of all the data transfer, so the data is end-to-end encrypted. So this network is also very much filled with security as job zero. So it very much had security in mind. So all the data that gets sent over the network is encrypted end-to-end, and is then made available as a data endpoint for you as a data or as an application owner. We won't have time to get into any more details today, but I'm really happy to talk to people. And then what we're talking about at the end is actually eResearch SA has made available some infrastructure for us to actually then store the data. Jim mentioned data storage. So this is very much another view of the scenario, but having the technology in mind. So the LoRaNet sensors, if you picture the possum boxes and things like that, would then talk over the LoRaWAN network and send sensor data to the back end, where we have a time series, so it's basically for graphing. We are storing the sensor values in a time series, and then we have a long-term storage. I'll mention a couple of technologies a little bit later. But we are also able to integrate sensors. So for example, at the Parklands where we're going to put some of those boxes up near Adelaide High School, we can send long-range data for some of those devices. And I've got some hardware devices brought with me if we want to have a look at it afterwards. So we have long-range devices that will send sensor values, but we also have the camera that Jim mentioned. So there's just an infrared camera that will connect to the Adelaide free Wi-Fi that we can pick up in that area. And then we use also some of the Bluetooth sensors to send all the data into that back end. Sorry. So just mentioning a couple of the technologies that we are playing with. So we're using the Raspberry Pi, which is an open hardware platform, probably the most predominant flat platform in this area, and I probably don't need to point it out to this audience. So these we use for the cameras, we use it for some processing, and as Kim mentioned, we have actually got some power management technology to be able to actually run this off solar cells. And batteries, we are actually able to power them down and up as needed. The other platform that is quite important in that area is the Arduino, and we've got one of those Arduinos that actually has a LoRa module already on board. And as you've seen in the video, I mean, just worth pointing out again that the concept of open hardware really was at work there, because the Amsterdam guys made the hardware design available openly, and even though they had some issues with the production of the hardware, there were other companies that were able to produce devices that are now shipping already. The Unos that you saw up there, they are already shipping. And there's because it is an open ecosystem, the whole LoRaWAN is actually an open standard. There is gateway devices and sensor devices coming on board. Unfortunately, there's not a great deal of off-the-shelf sensors for an industrial project, but that's not what we're about here. For what we're talking about here in terms of citizen science and about student work, there is plenty of technology out there. So that's a little bit of the software side, so the details of what we're using behind the scenes. So for the long-term storage and also for the storage of the reef watch data, we are having to cache data from the Atlas of Living Australia, because their API is a bit on the slow side with some of those queries for the mobile app. The responsiveness just wasn't there, so we have to cache a lot of data. Locally, we're using MongoDB, which is sort of the default NoSQL database these days. For the time series data, which is sort of the critical data for displaying real-time trends, real-time graphs, we use InfluxDB, which is a very capable open source time series database. For some of the storage that we don't do ourselves, I can highly recommend a project called OpenSensors.io. That's a fully self-contained and open environment where if you make your data available under an open data license, it's actually free to use. They do have private and enterprise versions of it, but that's sort of a very interesting data backend for Internet of Things if you're looking to use it in student projects. Ubuntu servers sort of run our backends, and we use various other software tools in terms of editors. I won't go into that. The last point, and I put it in bold, is really on the software as well as the hardware side of things. We really try wherever possible to stick with open standards. So if, for example, the MQTT transfer protocol. So there's quite a number of protocols out there, but we try to, wherever possible, stick with open protocols that are worldwide accepted standards. There might be some things that you could do a little bit more effective with other proprietary approaches, but the advantages of sticking with open for us have always outweighed the potential. So this is just the obligatory Star Wars quote for any techie presentation. So can we just move on? Because it's one more. Thank you very much for listening to the technical aspect. So if there's any questions now.